Good evening. All right, we've had a little poll open. Good evening, everyone. This is Linda Kingery, and I'll welcome you to Local Foods College. It's right at 6 o'clock now, so I'm going to give Rick Abrahamson the presentation, make him the presenter, and then we'll let him introduce himself, and we'll get started. All right, I think I can just do that. Here we go. Looks like we have a real good group online here. Rick, you should have access. I think there you do.
Alrighty.
I'm going to mute everyone else, and let me just remind folks that there's a little chat box. You'll see a blue line with the word chat in it, and if there's a question that you have that you want to kind of keep track of, you can just type it right in there. And I see a question there right now about sound. So I'll keep track of the chat box, and I'll invite you, Rick, to introduce yourself and go ahead with your presentation.
Alrighty, thank you, Linda. As Linda said, my name is Rick Abrahamson. I'm currently the horticulture instructor with the horticulture program at University of Minnesota in Crookston. I've been there for just one semester now. This just started my second semester yesterday, and I come to you today from downtown Minneapolis, where I'm attending the Green Expo with some students. So it's been kind of a crazy day driving to Minneapolis with the students and trying to figure out exactly what I was going to do here, finishing touches type stuff and whatnot. Anyway, a little bit of background. You may or may not, if you've been around for a few years, remember me from the past. I was extension educator in Clay County for 3 years, up until 2007 when I left to pursue a different kind of career at a botanical garden down there called Lauritzen Gardens, and it's a 100-acre botanical garden. If you ever get down to Omaha, I would suggest going there. It's a beautiful place, and you can actually see some of the soil stuff I'm going to talk about today here at that botanical garden in a couple of different spots. Prior to that, I was grounds manager at NDSU, where I oversaw basically anything that went outside of buildings at NDSU. And I've got a couple of claims to fame I'll quickly just kind of touch on. My first claim to fame, which I don't consider to be all that important, but it was at the time, was when President Bush, the first President Bush, came to NDSU, and I got a message from the Secret Service to order porta potties for the president. So, yes, I'm the guy that ordered the porta potties for the president. That's claim number one. Claim number two is that I planted the first ginkgo trees on campus, and we planted 5 ginkgo trees, and one of them is still going today. Unfortunately, they had some construction around that one in the last couple of years, and it's not doing so well either, but it was looking really nice up until about 2-3 years ago. So anyway, with that, our topic today is soil health, or soil quality, as most soil scientists will call it, but most farmers and whatnot go by soil health. And I too have a poll here, if I can figure out how to make this work. I don't see the polling tab.
Should be down toward the bottom there, the little stack. And
oh, there it is. It's up at the top on mine.
Okay.
We're going to go ahead and I'm going to ask everybody to quickly let me know a little bit about yourself here. I don't know if they can see it now or not. I'm a little not very. Oh, yep, we're getting some results here.
Okay, good.
That's pretty cool.
Yeah, that's nice.
It looks like there's still a few more coming in here. We'll wait another few more seconds here. I've got a few of these to do throughout the presentation. Hopefully they won't take too much time. So, what are we doing? Waiting for some are needing to submit, it looks like. And we'll show the results here so everybody can see where everybody's at. Maybe.
Rick, you might have to click that little button saying individual results. Check that little box there.
Yep. Okay. No, actually, poll results, I think, isn't it?
Poll results, maybe. Yeah.
Yeah. And then I don't know if you can see those or not. Before there was a share button as well. I don't see that now. Well, anyway, I'll just kind of go over it here. It looks like 5% of us are larger scale farmers, over 100 acres, and 7% of you participants are small scale farmers. 32% are kind of hobby farmers under that 10 acres, and 50% are home gardeners, which really tells me quite a bit about my audience here, so I can kind of talk a little bit more towards where the interest is. So we'll go ahead and get started here. Again, my contact information's on here, and do feel free to write down my email address or put it on the Moodle site or whatever, Linda, and so people, if they have any questions after the fact, can surely get a hold of me, and I do answer emails pretty well most of the time, unless it's all right. Organic matter, the key to healthy soils, and you're gonna see a commonality in this whole presentation that kind of surfaces around organic matter. Organic matter, I might refer to it as OM or as organic matter, but basically organic matter is pretty dang important in the soil. Without organic matter, soils would not be here doing what they're supposed to do. And just to reiterate, the soils are soils because they support plant life and have been changed through either weatherization and or biological changes from other organisms. So hopefully what you get out of the next bunch of slides here is you'll know what a healthy soil is. You will understand what organic matter is and why it's so very important in the soil. And you'll have an idea of how much organic matter might even be in your own soil in your backyard or on your farm. And you hopefully will know that soils are living. I probably don't have to tell anybody this at this point, but it's something that, you just have to realize, I guess. There are four main parts of soils. Mineral soils, for the most part, are 50% mineral solids. That's the sand, silt, and clay that are found in soils. Another 25% plus or minus, and you can see on this little chart when there's less air, when it's dry, there's more air, and more, when soil dries down, there's less water, stuff like that. But generally, there's about 25% air and 25% water in most soil, and about 5% of that mineral matter is considered organic matter. Organic matter is basically anything that's ever been alive in the soil or currently alive, at that matter. Living organisms, less than 5% of that 5% is living organisms. That's the worms and the bacteria, moles going through the soil, stuff like that. Anything that's alive in the soil, plant roots, bacteria. That fresh residue, about 10% or a little bit less than 10% of that 5% is fresh residue. So that's the plant root that broke off of the plant and is no longer attached to the plant, so it's dead. It's maybe dead insects in the soil. 33 to 50% of that 5% is decomposing organic matter. And that organic matter really doesn't do us a whole lot for plant growth. It does a whole lot for microorganisms in the soil, but for plant growth itself, it's not going to do much. It's that other 33 to 50%, that stabilized organic matter that most of us call humus. That stuff that's already been decomposed, and plants can get nutrients from that. It helps with the water holding capacity of the soil and a whole lot of other things. And we're going to talk about them in more depth here. I think I had I guess I didn't have a poll on that one. This is the soil food web, and you can see that on the left-hand side there, and I don't know if there's a way I can point to them or not, but that would be kind of nice to be able to do that. But you can see the little plants growing there. And plants have shoots and roots, and those roots will break off, like I said before, or they die back when you mow your lawn or cattle graze, or back in the day when the bison were on the plains, they would graze those grasses, and those roots would respond by dying back. And what that does is it releases organic matter into the soil. It also releases carbohydrates, hormones, and all kinds of other organic chemicals from the plant into the soil. That's when we follow that arrow down to that little brown stuff there that says organic matter. That's waste matter, and it also includes that, what bison do on the plains. Food goes in one end and comes out the other. That's organic matter as well, which gets into the soil. That organic matter feeds the bacteria, which in turn feed protozoa, nematodes, fungi, or fungi can feed directly on the roots and the other organic matter. And you can kind of see how the arrows are going around here, all the way up to regular earthworms, or even animals like the mole there, or birds that feed on insects and earthworms that are in the soil. So that's a pretty important concept for those organisms, but it's also a very important concept for our plants because they use that organic matter as well. I got another poll here. This one, oh, that's of course wrong button. Let's see here. This poll, oh, I did skip one, that's okay. Open poll. I'm going to ask you what color your soil is. So if everybody could chime in here and tell me what color your soil is. We'll discuss that a little bit. If you're looking at my slide, you can see that all the different colors of soil. Soils come in everything from black to red to yellow to grayish in color. A black soil typically will have 3.5 to 7% organic matter. So where I'm from Fargo, originally living in Crookston now. Soils are very black there. So it's a very heavy Fargo clay. And you can dig down in a Fargo clay, you can go, a foot, 2 feet, maybe 3 feet, and you're still going to find black soil in some spots. Lots of organic matter, tons of organic matter there. If you have a dark brown soil, like in the little picture there in the upper left-hand corner, you've got about 2 to 3% organic matter. If you have a yellowish brown soil, maybe the right-hand side, kind of in the next row in from that and down below that red one, you're sitting with about 1.5 to 2% organic matter. If you have a sandy soil, I'm getting some feedback here, maybe. so your color of the soil, and I've done this at presentations before where I've asked people, what color is your soil? They ask me, what can I do with soil? And I ask them what color their soil is, and they kind of look at me like I'm nuts. But bottom line is, soil color tells a whole lot about that organic matter. And let's see how our poll looks here. I'm going to go ahead and close this poll instead of having it go for a full 5 minutes. We got some good results here, I think. I wonder why you'd have to wait. Well, anyway, that's doing some waiting for somebody to respond. There we go. It looks like 29% of you that responded have black soil. So I would guess you're probably living in a prairie soil area and not so much a forested soil. 42% have a dark brown soil. You're probably on the fringes of the prairie. Yellowish brown soil, 8%. I'm going to just throw out there, and I could be wrong, but probably more of a forested soil. Reddish soil looks like 4% of us. Oh, no, nobody has reddish. About 4% are others. So probably, I don't know, maybe not such a great soil. I'm not sure where you're at, but typically the best soil is the black soil. And to give you an idea, I'm Norwegian. I'm going to come back to the, so I can see me. Oh, well, I'm Norwegian, and when the Norwegians came to Minnesota and North Dakota, I say this in joking, of course, the Finnish people were already there and had cut down a lot of the trees in northern Minnesota and started growing potatoes. And don't take me totally seriously here on this one. This is more of a joke than anything. I'll preempt it with that. But anyway, the Finnish people cut down all the trees and were growing plants, growing potatoes and whatnot. Us Norwegians got here and we said, oh, look at all this good soil. All these farms are here. We're too late. We can't get any good soil. So they had to go further west. And they got to the Red River Valley where the soils are very black, and they looked around and said, there's nothing growing here. It's all grass. There's no trees. This is bad soil. Well, I guess we have to use this bad soil, so they started farming that bad soil. And you know what? As us Norwegians always come out on top, you know, we got the better end of the deal. That's much better soil than you find in those forested areas. And the reason is, why? Organic matter. Grasses put a lot of organic matter into the soil. So we look back here at my slide again, sand, typically very low in organic matter, and a lot of those forested soils are sandy soils. I did my research on carrots in the Perham area and Mackville area of North Dakota, very sandy soil. It's still pretty black or very dark colored soil, still lots of organic matter, but not as good as if I'd have been trying to grow carrots in a clayey soil. Of course, we never would have gotten them out of the ground in a clayey soil with greater than 5% organic matter. Some other factors, rainfall, temperature, drainage, landscape position, and vegetation all make a difference on how much organic matter you're going to find in a soil as well. If we look at this little chart really quick, you can see these soils, the forest soil on the left-hand side. Depth of that organic matter might be, you know, up to 3–4% there, but it's very shallow because when the leaves of a tree, the trees fall off in a deciduous forest, where do they sit? They sit on top of the soil. When the needles fall off of a pine tree in a pine forest, where do those needles sit? On top of the soil. The only way that organic matter can get into the soil is to decompose and filter through, or if earthworms or some other animal buries that material. In a prairie soil, the sea soil there, the pink one, you can see that 12% organic matter almost at the very surface, going down to about a foot where we're still at 3% organic matter. And the reason that is because those roots, when that grazing took place, those roots let all kinds of good organic matter into that soil. So the other two images here show what actually happens after that soils have been farmed for some years, where that organic matter is even reduced more. So farming with conventional older style farming techniques is actually pretty bad on organic matter in the soil. Soils are very alive. There are lots of things in the soil that are living. Microorganisms, the fungi, the little springtail there, the worms at the bottom, centipedes, the moles, whatever. Research has shown that there are at least 85 naturally occurring compounds in soil from fungi that are toxic to insects. There's stuff in the soil that helps the plants to be able to control insects. There's stuff in the soil that helps the plants to be able to control disease or become more resistant to disease. So that soil is a very, very important. And what's important to those organisms in that soil? Yep, you guessed it, organic matter. Here's a picture of a root with some mycorrhizal relationships to plants, and I know there's a lot of folks feel that we need to augment our mycorrhizal fungi in the soil by inoculating, and I don't so much believe that. I feel it's just the opposite. The stuff that's there now is what we need to be feeding, and to do that we need to have plants that they can utilize. Advantage to those fungi: they get a food source, they get hormones, they get nutrients. Plant gets ability to get water from further away from the root, so this root can get water from all kinds of different surface areas than if it was just the root. They also get protection from disease and insects and even nematodes, as well as better uptake with nutrients. So part two to this presentation, there's 4 parts, by the way. I wasn't told how long I had, so I figured I could go all night long, right, Linda? We're going to talk a little bit about the physical properties, and I'm going to go through this kind of quick because I want to get to the meat and potatoes here. So we're going to talk about what soils are composed of, can soils impact plant nutrient availability, and how can soils be destroyed through conventional or any farming technique for that matter, or even not farming. We got another poll here coming up. Maybe, if I can find it. Well, that's not it. I'm not sure which one I was going to do here.
You see that little arrow?
Yeah. Really quick. Yep, I've seen it. Really quick, answer this question based on what you've already learned today. Which of these soils do you think is the best soil? Just see if you're listening. Okay, it looks like overwhelming success for prairie soils, and you can look at this question in a couple of different ways. So I mean, it's all right if you didn't answer prairie soils. There's no real right or wrong answer, except for urban soils. Urban soils would be a very, very wrong answer. I would be really shocked if I seen urban soils come up on that, unless you were messing around with me and wanted to make me go, whoa! Urban soils are very bad soils because we take all the good stuff out, we remove all that organic matter, and we bring in a whole bunch of other crud.
Rick, it works best when you're projecting your voice pretty loudly and toward your microphone, so I'll just... All
right, I will try to do that, but it's doing something here. Oh, it's waiting for the WebEx polling to end here. I jumped the gun a little bit. It won't let me do much. Okay. So anyway, we got that poll done, so that's good. Moving right along, I know I showed this slide already, but I just wanted you to see it one more time. Remember, half of mineral soils. Now we're not talking muck soils or organic soils. We're talking mineral soils. Half of those mineral soils are mineral matter and organic matter. 5% of that soil is organic matter, 45% is mineral. Minerals are what used to be rocks, weathered rock. About 25% air, and that's you'll find that in the macropores, and you'll find 25% water in the micropores in the soil. Anybody ever seen this triangle before? This is the soil texture triangle, and we know that sand particles are the largest particle size. Sand has a very low water holding capacity and a very low cation exchange capacity. I'll explain cation exchange capacity in a minute here, so just bear with me. Silt is a medium-sized particle, has medium water holding capacity and medium cation exchange capacity. Clay is the smallest particle size, very, very tiny. It has a high water holding capacity and a high cation exchange capacity. If you look at this triangle, you can follow this triangle. If you look at, say, 30% silt, and you follow that line going down from 30% silt, and you follow the line 40% sand, and then the line 30% clay, you have a clay loam. So if you have a soil that's 40% silt, 30% sand, and 30% clay, you have a clay loam. And those loamy soils are the very, very best soils, and they're a mixture of all three. And you can determine what kind of soil you have by using either the field test or the jar test. Field test, you basically take some soil in your hand, and they didn't let me bring any up in the hotel here, so I don't have any, but if I had some soil, I put it in my hand, and I could pour some water on that soil and mix it up in my hand. If I can make a ribbon with my thumb and forefinger, the longer that ribbon, the more clay is in that soil. Then if I take that mud pie, let's call it, and I put my thumb into that mud pie, if I can see the ridges of my thumb print in that soil, then that soil has a lot of silt. And if it's got a lot of sand, I can feel that sand in there. It's very gritty. The other way to determine the texture of your soil is to use the jar test, where you take some soil and you add water to it, you mix it up really good and get it all suspended in the water, and then let it sit for a couple of hours or maybe a couple of days, depending on how much clay is in there. And that sand will filter out to the bottom, or it'll settle to the bottom first, and then silt will be the next layer you see, and the last layer will be clay. And you can measure the length or the size of that sediment. You can measure that and determine percentages based on that. So that's how you can go ahead and come back and use this triangle to determine how much or what kind of soil you have. So your assignment for tomorrow is to go outside and get some soil and do one of these two tests or both of them to find out, what kind of soil you have. But you're probably going to need a jackhammer if you live in Minnesota, because the soil's a little bit hard right now. Cation exchange capacity, as we can see, our little cat friend here is positively charged. Cations are positively charged. And that's very important in soils, because soils typically are negatively charged, and they can hold cations. And that's why we call it cation exchange capacity, because soil holds that cation and releases it and exchanges it for other cations. So when that soil particle releases that cation can go into a plant. It's available for plant uptake. Potassium, ammonium nitrate, NH4+, calcium, sodium are all cations, and that's what our cation exchange capacity is. The graph you see here just shows different soils, sandy soils on up to organic soils, and how the cation exchange capacity changes on those soils. So again, cation exchange capacity is a very important concept, which, as you can see with the chart, organic soils that have a lot of organic matter in them makes a big difference. So here, another poll here, really quick. This was asking, why is CEC important? CEC is cation exchange capacity, and I've got a couple of different answers there. Because the cat photo rocks. Yeah, I'm seeing 4% of us like the cat photo, so that's good. Soil CEC gives us I can't even read the whole thing here, real good idea of what the fertility of the soil is. CEC gives us a real good idea of what the texture is, or a soil CEC tells us what crops we can grow. And to be totally honest with you, any of these answers are correct. There's no wrong answer. There's a cat photo rocks. CEC tells us about fertility. It also tells us about could tell us about what texture, and tells us what crops we can grow in that soil as well. So moving right along, I see we still got a few more. And you can see these little cartoons here. We have on the left-hand side a humus particle. That's organic matter. Lots of negative charge on organic matter. Lots of calcium and potassium and magnesium and even NH4 and even sodium, for that matter, can attach itself to that humus. Remember, humus is organic matter that's been decomposed. In the middle, we've got a clay particle. Again, lots of negative charge there, can hold lots of cations. And on the other little cartoon there on the right-hand side is an organic chelate. An organic chelate is kind of a different particle in that it can hold a cation in the middle of it, and plants can actually use that organic chelate. So if you've heard about iron chelate, that iron molecule is in the middle of this organic molecule. The plant takes up the organic molecule, breaks it up, and then can get the iron that way. So it's a little bit different than just taking up the iron. It takes up that whole molecule. Soil structure, another important property of soils. You can see different soil structures here in this little cartoon. Single grain structure in the upper left-hand side. Very rapid infiltration of water. Very, very small chunks of soil, shall we call them. I don't want to say texture because texture is sand, silt, and clay. Soil structure is the structure the soil takes because it's being held together by organic compounds like sugars and whatnot. Blocky in the middle on the top there. Moderate infiltration of water. Platy on the top right-hand side, very slow infiltration of water. So if you dig into your soil and you take out a chunk of soil and you kind of break it up, what shapes do you get? Do you get this kind of platy? Do you get these blocky shapes? Do you get a granular shape, which is similar to single grain, only a little bit bigger? Fargo clay, you will get usually granular structure from a Fargo clay. It has to be the right amount of soil water or you'll never break it apart. But if you can get it broken apart, you'll probably get granular. Prismatic, moderate water movement through prismatic soils, and then massive on the other end. They're very slow moving. That's a very bad soil if you have massive. You're going to have a tough time growing a lot of crops in that soil. The best ones, granular, single grain, and probably blocky. Prismatic is not really good, although some plants can get through that pretty well. Soil pH. Soil pH is a scale, a pH scale. 7.0 is neutral on the pH scale. If it's under 7, it's acidic, and if it's above 7, it's alkaline or basic. Now, I would like to point out, if you can see the numbers on the top part of that little diagram, it says 0 at 7. 7 is 0, 8 is 10x, 6 is 10x, 9 is 100x, 10 is 1000x. pH is a logarithmic scale, which means that it's not a straight line, it's a curved line. So to go from a 7 to an 8 is 10 times more alkaline than a 7. A 9 is 100 times more alkaline than a 7. A 10 is 1,000 times more alkaline than a 7, which is why changing the pH of soils doesn't work so well. It's tough to change the pH of soils, especially if you have a soil with a lot of calcium carbonate in it. It has a high buffering capacity. Soils in the Red River Valley, not so much in the forested areas of Minnesota, but in the valley areas, are going to be very high in buffering capacity. That means they typically will have an 8.0 or 7.5 pH. If we lower it by adding sulfur If we lower the pH, it's going to come right back up to that 7.5 or 8.0 or whatever. So we can change it, but not very good. When I was working extension, I had people call me every now and then asking, how much lime do I have to use to do this? How much, how much do I have to add to soils to change the pH? And my advice was, don't even try, because you're going to go crazy trying to get our soils to change pH.
Rick, there's a question in the chat box about adding wood ashes. So does wood ash spread on a pine forest soil help to reduce the acidity?
Wood ash would actually change the pH a little bit. It would reduce the acidity or increase the pH slightly. Typically, wood ash is used to add potash to the soil, but yeah, it would change the pH a little bit, and it probably wouldn't buffer back as much as the higher pH soils would. So yeah, that would be a good idea. There's a reason why, if you're familiar with the rainforests of South America, they burn them, slash and burn them, and then they plant crops. Well, that's the only way they can get nutrition from the soils, by burning those rainforests. So yeah, wood ash is a great thing to add to soil. Not as good as organic matter, though. I'll tell you that right now. If we look at this chart right here, this is a chart that shows us availability of nutrients, plant nutrients in different pHs of soil. And I would ask, what pH is best for most plant growth? If we look at that, we can see that the wider that line is, the more of that nutrient is available. So look at the top, nitrogen. The wide part of nitrogen is available from 6.0 up to about 8.0. Phosphorus, more available at 6.5 to 7.5. Potassium, 6.0 on up. Sulfur, 6.0 on up. You can kind of get the idea. So if we look at this chart, we'll see that between 6 and 7, 5.5 to 6.5, someplace in there, most nutrients are going to be available for plants to be able to take up. At pHs above 7, 7.5, 8, you can see that iron line getting real thin, the manganese line getting real thin, the boron line and the copper and zinc line getting thin as well. Those micronutrients are changed into a form that plants can't take up. So they're virtually not there anymore, which is why if you are from the Fargo or Red River Valley area or Grand Forks, Crookston, whatever, and you see trees, maple trees in town that are yellow, that's why, because the pH of that soil is too high. Just really quickly, macro and micro. Macronutrients are those that are needed in high amounts in the plants. This is plant tissue in the little chart on the table on the right. The 4%, 4.0% nitrogen, that's nitrogen in plant tissue. Plants need a lot of nitrogen, they need a lot of potassium, quite a bit of phosphorus, calcium, manganese, and sulfur, and the ones at the bottom, the micronutrients, that just need a little bit of those. And kind of the reason we call them micronutrients or macronutrients is that macronutrients, we can induce deficiency symptoms. We can take nitrogen away and we can see yellowing leaves. And I'm not going to talk about all the deficiency symptoms there. You can read those over quickly yourself or look back later on the video. Micronutrient toxicities, we can induce toxicity symptoms by giving too much. So boron, for instance, if we give too much boron to a plant, it's going to start to get sick because of a toxicity of that boron, because plants only need a little tiny bit of boron. In our soils, what we find, if we're not managing them correctly, is that it degrades in kind of a spiral fashion. So if you start off at the top there and it says intensive tillage, soil erosion, and insufficient added residues, it goes down to soil organic matter decreases. So we've found that by tilling the field, we actually reduce soil organic matter. Well, then that spirals down to where aggregates break down. That's the structure of the soil. And then the surface becomes compacted and the crust forms. and then you get more erosion by wind and water. Remember most of us probably don't remember, I surely don't remember the Dust Bowl days, but that's what happened there. As it started spiraling down, we were not managing the land properly, and we got to where wind would take that, and there wasn't enough moisture to hold it down. Wind took it, and it became the Dust Bowl times. So more soil organic matter is lost, and that spirals down to less soil water storage, less diversity of soil organisms, fewer nutrients for plants. Just keep spiraling, crop yields reduced, hunger and malnutrition eventually could happen or did happen during the Dust Bowl. So we find that happens. It can happen with as simple as in intensive tillage or even just soil erosion, just something happening, not managing properly. And I mentioned soil crusting. Soil crusting happens when the water doesn't go through the aggregated soil correctly, and it causes a crust on top of the aggregates. It kind of breaks down into a finer soil on the very top of the soil, and that becomes a crusted soil. And I had problems with that with carrots that I was growing out at the Absaraka Horticulture Farm, NDSU's Absaraka Farm, where we would plant carrot seed and then get a heavy rain, and lo and behold, the soil would crust and the carrots wouldn't come up. So that can be very detrimental to plant growth with a crusting soil. And that typically would be a more sandy, finer, well, sand's not fine, but a more sandy and silty soil than a clayey soil. It's going to have more problems with that. Now, clay soils have a bigger problem with soil compaction. So driving on that soil, working that soil, the tractor, walking on that soil, whatever, all compacts that soil. And good soil structure on the left-hand side there, the A cartoon, we can see the plant roots have gotten down into that soil, down even below that topsoil. Water can get through there, air can get through there. On the other little drawing there, the soil's compacted, plant roots can't penetrate, air and water can't get in there, you get a surface crust, seeds can't germinate, very tough place for plants to grow.
Let me just interrupt for a moment here, Rick. We have a couple of questions. Are you getting to a place where you're going to show how to improve quality? You talked about the degradation. Are you going to talk about reversing that, or otherwise I could just ask these questions directly?
Yes, I'm going to talk about what we can do to change that, and then if there's other questions on that, we can address them at that point. Is that okay?
That sounds great. Thanks.
Okay. Tillage time, you want to till when the soil water content's that perfect amount, and that's hard to tell. You can see on this little chart here, sand or clay. Sand is very loose when there's not much water there. When there's enough water there, it'll be friable. You get too far, it becomes plastic limit or plasticity. You want to till when you're in the friable range. Now for Fargo clay, I'm coming back to that because I got lots of experience there. The best you can buy, the worst you can use. You got about a 2-day opportunity to till that soil with Fargo clay, or you're either too hard or too plastic. You know, in the spring, you don't have much time. Tilling during the wrong soil conditions, you get cloddy soil. Anytime you get cloddy soil, you want to try to make that, pack it down and make it, pulverize it, make it more of a fine seed bed. And what do you suppose you get? You get raindrops that disperse the soil aggregates and cause that crusting. So tillage at the right time would not have this result. You would not have this cloddy field. Just really quick, saline versus exotic soil, if you've heard those terms before. Saline soil has electrical conductivity, or an EC, that's greater than 4 decisiemens per meter. That will harm sensitive crops. That means there's lots of salt in that soil. Acidic soil, on the other hand, not only has lots of salt in that soil, but most of that salt, or more than 15%, I guess it's not most, but more than 15% of the cation exchange capacities are occupied by sodium. That makes it a sodic soil. So you can have a saline soil that's not sodic, or you can have a sodic soil that's both sodic and saline. So if you have something that looks like this picture, that's a sodic soil. You're not going to be able to grow very, very well in that. There's very few plants that will be able to survive in that soil. And that can happen by improper management of soil as well. All right, part 3 here. Does soil health, plant health, and pests interrelate to each other? We'll talk a little bit about that. How can I manage soils for high quality, which is kind of the question that was just asked. And how can I manage soil water, and how can I manage soil nutrients? This chart shows how different management practices can impact gains and increases in organic matter and enhanced beneficials, or stress pests, as we could call it. If we add materials like manures, compost, or other organic materials from off of the field, we will have a gain of organic matter, and we will not have a loss, okay? But we will enhance beneficials and stress those pests. If we better utilize our crop residue, we have a gain, and we have an enhancement of those beneficials. We use a high residue producing crop. You can read it for yourself. Cover crops, we'll talk about that. Gains increase, losses decrease, enhanced beneficials. So that's that organic matter, doing something that reduces tillage and increases organic matter, or conserves organic matter, is going to help in the long run, not only for the soil, but for the plant growth as well. Of course, that's the goal, right? Carbon-nitrogen ratio, you maybe heard that term before. A high CN ratio has low nitrogen amounts. A low CN ratio has a high nitrogen amount. That's kind of the take-home. This little chart here just shows different materials and what the CN ratio is. So if you're adding oak leaves to your garden, for instance, you have a 90 CN ratio. That means you're not adding a lot of nitrogen, but you're adding a lot of carbon. If you're adding poultry manure, you're adding lots of nitrogen and less carbon. So that all makes a difference. High CN ratio is going to tie up nitrogen. So this little chart here, we see the little red area there. You will have a short-term reduction in nitrogen availability. So if you've ever seen a landscape bed where the plants are kind of yellow and it has mulch in that bed, it's because that mulch is tying up all the nitrogen. As the bacteria feeds on that mulch, it's tying up nitrogen, plants can't get it. Whereas if you have a low CN ratio, that's going to release nitrogen into the soil. So depending on what your goals are, you want to pick the right organic matter. If you want nitrogen, you have to have that nitrogen-containing organic matter. This just kind of shows different properties, biological properties, physical properties, and chemical properties, and how they all play into that healthy soil. So it's very important that all these things, good till, surface structure, playing into it. Biodiversity is important to keep that biodiversity, keep the pH. It says near neutral. I kind of disagree with that a little bit. I think it should be a little lower than neutral. Water holding capacity in soils is driven by the texture of the soil. A sandy soil is going to have a lot less water holding capacity than a dense clay or an aggregated loam soil. Kind of the take-home message here is you see the place that says wilting point and the field capacity point. That's where you want the water in that soil to be at all times. If it's above field capacity, plants will drown. If it's below wilting point, plants will not be able to get water, and they will die from drought, basically. And of course, infiltration versus runoff. Runoff, you lose all the water, so you want it to go into the soil, and that can play a definite part in that organic matter on that slope or on the top of that hill. So, in answer to the question, cover crops. Cover crops are a very important way to conserve organic matter and add organic matter. So, growing legumes. when you're not growing the crops that you're growing. I know that's difficult in some areas. I manage a campus garden at UMC, and we haven't even started looking at cover crops as an option yet, but rest assured we're going to. You know, since I'm the manager, I guess I get to make that call. Anyway, winter annual legumes like field peas and hairy veg, summer annuals like soybeans, depending on when your growing season, what you're growing, biennial and perennial crops of alfalfa, crown veg, some of the clovers. All of those will add not only organic matter, but also nitrogen, because this is a legume, it does fix nitrogen, so you're adding nitrogen as well. In the little diagram there, we see cover crops enhance, add organic matter, enhance mycorrhizal numbers, add nitrogen, suppress weeds, do all kinds of stuff. And that can be as simple as putting that material between the rows of your plants as an organic matter, or growing crops for carrots, for instance. When carrots are seeded, they're seeded in a double row or 2 rows on top of a hill, and then a plane comes along and seeds barley on top of that to act as a cover crop. So that cover crop's going to do all these things: reduce erosion, increase infiltration, protect those plants. Grasses, winter rye, oats, annual ryegrass, Sudan grass, and then buckwheat and brassicas will work as well for cover crops. What that means for you, those of you that are larger scale farmers, all the way down to the gardeners, depending on what your crop is, you can use that cover crop over the winter. There's fields I see every day going to work from where I live that have winter wheat on them. Now, winter wheat's growing as a crop as well, but it's still acting as a cover crop during the winter time here. So in the A chart there, main crop is growing during the summer, cover crop is growing fall through spring. In the B chart, cover crop is growing between 2 main crops. Probably not going to do so much of that in northern Minnesota, but if we look at the other side of the vegetables, we can grow early vegetables and have a cover crop, and then grow early vegetables again in the fall. So that cover crop maybe it's peas, for instance, not field peas, but garden peas during that, when we're not growing those lettuces and those cabbages. So, and then again, another cover crop after that. Going to reduce erosion, going to increase organic matter, do all kinds of good things for the soil. The other ones kind of overlapping, you know, again, interplanting, where you would plant maybe radishes and lettuce, and or maybe the cole crop's a better example. You know, the Three Sisters, where they grow, I can't remember, squash and beans and corn together, all doing the same thing. Those plants are all needing different stuff from the soil, and they're augmenting each other as they grow by adding to the soil or adding some way for that other plant to grow onto it. How we do it on time? I'm running out, aren't I? I only got another 35 slides, so we're halfway through. Crop rotation, another thing you're going to want to do for sure. Crop rotation, not only to protect from disease and insects, but to increase organic matter. We see the chart here. This is corn, but moldboard plowing corn for 25 years, organic matter goes down, and then by planting, you know, hay or alfalfa in that area for the next 50 years, that organic matter is going to increase. So when crop rotation, and this is just one suggestion, surely there's tons of other ways to rotate crops. Year 1, sweet corn, followed by hairy vetch or winter rye cover crop. Year 2, pumpkins, winter squash, followed by rye or oat cover crop. Year 3, tomatoes, potatoes, peppers, followed by that vetch rye again. Year 4, the crucifers, greens, legumes, carrots, onions, other miscellaneous vegetables, followed by a rye cover crop. If you got lots of land, you can do year 5. Most backyard gardeners probably don't have that much space, though. Year 5 is that fallow year, where you're planting that oats or red cover clover or buckwheat or something like that, to just grow that to add organic matter, right? I put this in not so much to talk about manure or nutrients in manure, but to show you that there are differences in the amounts of nutrients in manure, depending if it's dairy cattle, beef cattle, chicken, or hogs. So take a quick look at that, and you can see that the nutrients in those manures are different. So it's going to also depend on what you want to get out of that. Here's an important concept. Manure does impact organic matter because it is organic matter. If we look at the original level there of organic matter 5.2, we can see that after 30 tons for, I think it was 15 years, it increased to 5.5, which isn't much, but it decreased before that. We can see the CEC change a little bit, pH changes a little bit, phosphorus and potassium change quite a bit. Composting is another thing that you're going to want to take a look at. These pictures are just different composting techniques. It's kind of a bigger farm might do the one in the left upper photo. The one in the right upper photo is maybe a small family farm or a gardener. That's basically a compost, just a small compost pile. And of course the bottom one is large, very large scale. Grass clippings hold 77% moisture and 45% C or carbon and 2.4% nitrogen. Remember the carbon-nitrogen ratio. The green stuff has lots of nitrogen, brown stuff has lots of carbon. That's kind of the important thing there. Let's move on here. Erosion, another way your soil can be lost. Obviously, the entire soil is lost. The picture there shows a Midwestern cornfield after a very heavy rain, took lots of soil away. The other picture is because of a slope and steep lands, taking a little bit slower, but still all the topsoil is gone. So you need to protect from erosion. Cover crops will do that. Organic matter in the form of a mulch will do that as well if you do have a highly erodible crop or highly erodible soil. Soil compaction, working that soil when it's too wet, you can end up with this smearing that you see in that first photograph, the tractor tire going through there. If you can see your tractor tire that well going through, you're not tilling at the right time if you're trying to plow that field up. Very plastic, very wet. The wheel traffic's in the middle, plowing, and kind of they did this right outside your office, Linda, if you recall. Last summer they were trenching in those lines. You see those trenches they dug with that, and they didn't even trench it, they just plowed them in, but still there was a 1-inch trench that they left behind, and they filled it up with sandy loam, I'm sure. I know they were out there with some soil and they were filling those cracks up, and that's not going to work so well. Those cracks will be there, 5 years from now. It's going to take lots of freeze thaws to get rid of those cracks. So mark my words, we can watch that together. If you irrigate on your farm or in your backyard, especially if you're on a larger scale farm, the picture on the left there shows tensiometers. I would suggest you get a couple of those. What those do is they measure soil water potential. And you can take that number that you see on that chart, and I didn't have a close-up picture, but you can see the dial there. You can read that dial and determine when you need to irrigate. Because when the soil potential, water potential goes down so far, then it's time to irrigate. You want to keep that up. That'll help you keep your soil moisture level at the right level. The other picture shows a organic mulch that was added between the rows, and underneath that mulch is a drip line. Probably the best way to irrigate backyard gardens or small farms is to use drip line or drip tape as opposed to overhead irrigation. Overhead irrigation is quicker if you happen to forget, whatever. That happened on our farm or on our garden, campus garden, and I ended up having to water the sweet corn with overhead, and that was tough to do, but we got through it. But anyway, drip line's much better with the mulch because that'll help to hold that water in there. So let's bring it all together. See, we're getting there. We're going to be there. We skipped those polls. That seems to help. Sorry. Soil testing. How many of you soil test? Ask yourself that question. Do you soil test once a year? Do you soil test twice a year? Do you soil test every 3 years when you feel it might be necessary? Or have you never soil tested? If you've never soil tested, do so. Soil testing is very important. It will tell you a whole lot of stuff about your soil. If you soil test every year, thumbs up to you. If you soil test every 2 years, if I had 4 thumbs, I'd have them all up right there. If you soil test it every other year, that's better than nothing. But you really want to get a kind of a baseline as to how that soil is reacting to your different cropping methods. So don't guess. Let a soil test help in your crop production, even in your backyard garden. I know I probably will catch heck for this, but it's NDSU's soil bag. I don't even know if the University of Minnesota has a soil lab anymore. If they do, please email me and let me know, because I do want to support U of M. However, I did go to school at NDSU and did my master's there in soil science, so I'm kind of torn between the two. It doesn't matter where you send it, though. You're going to get results regardless, so send it to wherever you want. I'm not going to read through all this. You can read this later. This is just kind of guidelines for taking soil samples. When I take soil samples, what I do is I grab a couple of 5-gallon buckets, a spade, and a trowel. A trowel is that little shovel you use in your garden, I dig a spade full of soil out, and I take one trowel full and put it in a bucket. And I go to the next one, same thing. Next one, same thing. Just kind of randomly throughout the garden, mix it all together, and fill my bag up with what's in that mix. And that works really well. So if you read through that, hopefully that's about what it says, and it does. You'll have a chart like this or a sheet like this, depending on where you send your sample to. Fill that out. I suggest nitrogen, phosphorus, potassium, pH, soluble salt, and organic matter. All of those are the big ones. You can also do the sulfur, zinc, iron, and other things too, but that's not going to tell you a whole lot of useful information, especially for the backyard gardener or the smaller farmer. You'll get some results that look like this. Maybe kind of hard to see, but we can see the pH is 7.4. Nitrogen, 0 to 6 inches is 10 pounds per acre. Organic matter, 6.7%. This is a nice organic matter garden in Moorhead, actually. Phosphorus, I think that says 89 parts per million, which is really 160 or 180 pounds per acre. And potassium there, 425 or something. That's more potassium than you can shake a stick at. You never have to add potassium to this soil. There's a lot in there. And a lot of times those NDSU and University of Minnesota, if they have a lab, will give you, not only give you the results, they'll give you some advice too. If not, your extension educator, whoever they might be, can. Kind of a soil health indicator, very important if you're seeing earthworms, or your organic matter and your color. Those all tell us a lot about that soil. That's why I asked you what color soil you have. If you have organic matter residues, very good soil if you're finding this stuff. Root health. Look at the root. This picture down here, take a plant, dig a plant up and look at the roots. If you have a lot of white, light-colored roots, awesome soil, awesome healthy roots. The guy there is checking for compaction in that soil with a tool that measures that compaction. You can do that. You don't have to have that $150 tool. You can take a big old screwdriver out, stick it in the soil and tell how compacted it is as well. So you can read through that at your leisure. You confused? Bottom line is, whatever your farm or your garden, whatever your philosophy is, as long as you're reducing your tillage, you're not going through there with a whole lot of tilling every single year. You're rotating your crops, you're controlling some of that erosion, you're maybe using cover crops. Maybe not all of these fits everybody's philosophy or their ability, and that's okay. Bottom line is you kind of custom make it to fit your own farm. I think we're getting just about there. This chart here shows us different tillage practices and how it reduces soil health, and except for strip tillage or no tillage, zone tillage, etc. Down to organic matter, bedded manure, very good, improves soil health. Liquid manure will also increase soil health, although not as much because it doesn't have the solids as well. Compost, very, very good. Cover crops, very good, and crop rotations as well. To be honest with you, this chart kind of just says what this thing over here says. So reduce your tillage. You know, don't be chisel plowing out there, or unless you have a compaction problem, then you got to dig down deep and break it up. So I mean, there's exceptions to every rule. Not going to read this. Don't worry about that. Just for your reading pleasure later. Different physical concerns and how you can overcome those. Final take-home message. One more poll before I ask for questions. I know there's probably some. This was actually my favorite poll. Where did it go? Take-home poll. Here we go. Hopefully you'll get a little kick out of this one. What's the final take-home message of the last hour plus 6 minutes? That's not too bad. Final take-home message. Organic matter is top dog. Organic matter is what really matters. Organic matter, organic matter, organic matter, or organic matter is awesome. Of course, all of the above. I should have had that one there, but it looks like you're having fun clicking anyway. So with that, I would ask if there's any other questions. Organic matter, you know, I tell my students, I teach horticulture, so I don't get to talk about soils a whole lot, but I do talk about it in the intro. And excuse me, I tell my students that on occasion, if you don't know the answer to the question on the test, if you answer organic matter, you've got a pretty good shot at getting something for it. So they understand that too, because I'll ask them a question like, you know, what is photosynthesis? And they'll say organic matter.
Rick, there are a few questions in the Q&A. I'll just read them and you can respond. Actually, the first one is about getting a copy of a particular slide, and I'll let you know that we'll have all of Rick's slides posted as a PDF document on the Moodle site sometime tomorrow, maybe even sooner than that, so you can see that. Then there's a question about recommending nutrients if the soil test. Let's see, how would you recommend adding nutrients if a soil test shows low in iron or low in either K or P?
Okay. How would I recommend adding nutrients? Well, K and P you can add. It would be good to know what the nitrogen content was on the soil test as well. Chances are you probably have to add nitrogen too, but you can use, if you're going to use a synthetic fertilizer, for instance, you can use a balanced fertilizer, you know, maybe just throw a number out with a 1-1-1 ratio, 10-10-10 or something like that. Now, keep in mind that phosphorus in Minnesota, and my assumption is that you're in Minnesota, you have a low phosphorus, you can add phosphorus to a garden, and I'm assuming it's a garden. So that's okay. For an organic type, using organic matter or something like that, you're probably not going to be able to do that just with that. You could get the nitrogen that way, you can get some of the phosphorus, some of the potassium, but you're probably going to have to add some superphosphate or some potassium nitrate would work, or even potassium chloride, just to increase that potassium amount. Depending on how low it is, I'd really need to know the number to give a recommendation, though. And then the iron question, iron sulfate or chelated iron, but chelated iron is really, really messy. Again, I need to know the pH to give a real good recommendation, just guessing off the cuff here.
Okay.
If they want to email me their soil test results, I'd be glad to take a look at them, though.
Okay, there you go. Do pine needles make a good mulch or compost?
Pine needles are an awesome mulch and a compost both. When I was grounds manager at NDSU, we'd have a spring cleanup day, and we'd have all the staff come out and help us clean up the grounds. And every year they would start raking the pine needles out from underneath the pine trees. And I would be going, no, don't do it. But on the other hand, you don't want to go yell at them either, because they're volunteering. So, we lost a little organic matter, but pine needles are great. It's better if they're composted. Putting pine needles right on as a mulch is fine in a garden or whatever as a mulch, but as it breaks down, it will tie up that nitrogen. The microorganisms start feeding on that pine needles. It's going to tie up the nitrogen, and you're going to have to add some more nitrogen so your plants have some. It's probably not going to change the pH a whole lot if you have a high pH soil. Maybe just a little bit, but not a whole lot.
Good. In the chat box there's the URL for the soil lab at the College of Food, Agriculture, and Natural Resource Sciences at the U of M. So
I just didn't know. I'll be honest with you. I should have done my research, but great. I'll look at it.
And I think we could just open it up now. If you have a question, well, there are a couple of questions in that chat box. There's one about gumbo soil. What about gumbo soil? Is it good or bad, and should it be altered in any way?
It depends on what his or her definition of a gumbo soil is. A lot of people will call a Fargo clay soil gumbo, and it's if it's wet, it's nasty. But Fargo clay, if you're trying to grow crops on it, or, basically any plants is going to do great on Fargo clay. So to change a gumbo soil, assuming that's what we're talking about as a clay soil and not an organic muck soil, there's a difference there. If we're talking about a clay soil that's more than 50% clay, like a Fargo clay is about 80%, guess what my answer is going to be, Linda? Organic matter. Organic matter. The best thing you can do to add to soil is organic matter. Organic matter will not only break up the soil, it will help it to increase its water holding capacity, it will help to increase the nutrients, all the things I said plus a whole lot more. So if they want to make gumbo soil better, add organic matter. My dad gardened in his backyard for 20 years. And I kid you not on this. 20 years later, after he started gardening in the backyard in Fargo, he said to me, this soil's getting pretty good. And he added organic matter every single year for that 20 years. As you think you're adding a lot, if you're gardening, till it up, put about 6 inches, 4 or 5, 6 inches of peat on top of that, or compost or something like that, and then till it in. And it's not going to change the soil overnight. It's going to take a long time to do it. But I'll tell you what, he had a pretty sweet garden after 20 years.
Great. Well, I think if any of the people in attendance want to unmute themselves, that means find your name in the list and click the little orange microphone. It'll not be orange anymore. Then you'll have a live microphone, and you can just ask your question out loud. I think we have gotten through the questions that were posted. Let me just take a quick check. I guess one question that is posted there, Rick, is it possible to put on too much wood ashes in a garden? I would say no. Personally, I don't have a whole lot of experience with that on a larger scale.
being a city slicker, I guess. But I don't think you can do too much, because what's going to happen, you'd have to add so much wood ash. Now, maybe if that person that asked that question heats everything with wood and gets this, pile that's, just massive, yeah, then maybe probably too much. But again, if my suggestion would be to add that in a 2 or 3 or 4 inch on top of the soil, mix it in, do that once a year. I think it would be fine. A normal person probably would never get too much. And I don't mean that with any disrespect, of course, by saying normal, maybe that's the wrong word to use, but most of us probably don't have that much wood ash to have too much. But if you're adding 8, 9, 10 inches on top, that might be a little bit heavy.
Anyone else have a question you'd like to ask out loud?
They're all scared after I said that guy wasn't normal.
Someone did point out that you could, if you have a high pH soil anyway, you could continue to raise it by adding wood ashes. So.
Yeah, it would make if you have a high pH soil, you probably, I didn't think of that. You don't want to add too much in that instance. So, again, the problems are going to be with your nutrient availability, and you're probably not going to want to add wood ash at all if you have a 7.5 or 8.5 pH soil.
Here's a question from right in Crookston. I have a couple of pretty sickly looking maple trees. I was told that soy green might improve them. What would be your recommendation?
Oh, tell us how big they are. How big are they?
And Connie, if you'd like to just unmute your
sometimes it's good to have more info.
Here, I'll unmute you, Connie, if you'd like to just talk a little more.
Well, I'm new to the area, and so when I moved here, the leaves were curling and yellowing, and they're spindly. One is about 20 feet tall, and probably the others 15, but not very much birth to them.
When did you notice it?
In our area.
I'm sorry, when did you notice the problem?
Well, I moved into this house in June.
Okay. The curling of the leaves could be part of this as well, but definitely the yellowing. It's probably nitrogen deficient, or not nitrogen, I'm sorry, iron deficiency or magnesium deficiency because of the pH of the soil. So you have basically 3 options. You can reduce the pH of the soil, which I've already said during the presentation probably isn't going to work very well, or you can add iron 1 of 2 ways, either to the soil or to the foliage itself. What I've found is, or you can do an implant on the tree, you could try that. What I've found is spraying the foliage with either ironite or iron sulfate or even Miracle-Gro with iron in it. Miracle-Gro has iron, the plant will take it up through the leaves. If you can spray it on the leaves, you're probably going to have the best greening up as to any of those. The problem with putting it into the soil is you have to use a chelated form, and it's nasty, but you have to put so much, the idea is you put so much in the soil that you're going to force it into the tree. So if you look on the University of Minnesota Extension yard and garden sites, they have a publication on there that tells you how to do that. You drill successive holes underneath the tree and you spoon in, a tablespoon or something like that in each hole to try to force it in the tree. The other option is to drill a hole in the trunk and put an iron capsule in the trunk of the tree to try to get iron to the leaves. If you can't get it to green up, it's not going to survive. Your other option is to cut it down. So once they get that big, they're in essence starving to death because they can't produce enough chlorophyll, because iron is a central molecule and chlorophyll can't become green, so it can't photosynthate, so it starts using all of its reserve sugars in its roots and then eventually starves to death. And unfortunately, you know, you can get it to green up with one of those methods, it'll keep going, but if it can't, it's going downhill fast at this point, my guess.
One more question here in the Q&A pod is, how long does it take for field peas to release nitrogen after you plow them in? Or
well,
plow them down?
They have to decompose, so you're probably looking at anywhere between, depending on the conditions, the time of the year, anywhere between 30 days and 120 days. You know, if you plow them in the fall, when it's starting to get cooler, it's going to take longer. If you can plow them in and they have August still, or, you know, or you have a late fall, late frost, it's going to be quicker to get that released. But remember, they're going to release nitrogen even as they're growing, so that's going to help as well.
Yeah. All right. Well, I'm back. I moved us back to the front slide where you have Rick's contact information there. These slides, this whole packet of slides will be posted on the Moodle site momentarily. Well, sometime tomorrow. Karen Lanthier is on, and she'll get that done as quickly as she can. There, thanks. I guess
I was still in control.
You were in control, right? I was only moving my own, I bet. So I will just I'll unmute everyone, and we can say thanks to Rick for his presentation tonight, and feel free to email or call Rick as he invited if you have another question that comes up as you're preparing for the next season. So
to do that.
It was pretty good.
Thank you.
We're going to matter. Really, you know, he says it's all ill.
Do feel free to call on me. I do answer emails. I don't always answer my phone, but I do answer emails real well. So, Connie, you as well, if you're still on there, if you'd like next summer and want me to come and take a look, I do that too sometimes. So, I'm around campus with that garden. So.
All right. Well, thanks very much, Rick, and have a great time at the Green Expo.
Thank you.
Sounds like a...
Wasn't too long-winded.
Yep, this worked out just fine. Thanks so much.
Mm-hmm.
Bye-bye.
Bye-bye.